When we multiply radicals, the rules are different than when we add or subtract them. So we're going to follow the steps up on top to multiply each of our examples below. So first we're going to multiply the numbers inside the radicals. Then we will multiply the numbers outside of the radical. Then we will simplify the final answer. So if I wanted to do number 1, square root of 3 squared, I'm going to write this in expanded form. So if I did that, I would get root 3 times root 3. I know it's 2 times because of the 2. So I'm going to multiply root 3 times by itself twice. The square root of 3 times the square root of 3 is the square root of 9. I also happen to know that the square root of 9 is a perfect square. In other words, if we expanded it again under the same root, we have a pair. Therefore, we cross one out and bring the other outside. Our final answer being 3. The reason for this, a square undoes a square root. They are opposites of one another. So whenever you see it written like this, you can know that your final answer is just going to be the radicand. That is the shortcut. If you can't remember the shortcut, that is okay. You can walk through these steps and still get to the same answer. Now our next example, 2 root 12 times 4 root 3. I'm going to draw a line connecting my outside numbers so that I remember to multiply them. 2 times 4 is 8. And then I'm going to draw a line connecting my inside numbers, my radicands. 12 times 3 is 36. Do not forget the square root sign. The square root of 36 is a perfect square. A perfect square is a number that can be written as a whole number. So the square root of 36 can also be written as 6 times 6. That is a pair. I cross one out and I bring the other outside. Therefore, I'm going to have a 6 on the outside and I'm going to have an 8. The 8 is already outside. I'm going to multiply those numbers together to get my final answer, which is 48. Remember to multiply, do not add. Lastly, we're going to look at a distributive example. Distribution means we multiply the outside numbers to the 2 inside. So I'm going to put a 1 on the outside of this just so that I remember that my coefficient or my outside number is 1. So 1 is a whole number and so is 3. 1 times 3 is 3. The square root of 3 has nothing to multiply by, so we're going to leave it as square root of 3. Now I'm going to multiply 1 square root 3 times 4 square root 3. 1 times negative 4 is negative 4. The square root of 3 times the square root of 3 is the square root of 9. We know from example 1 that the square root of 9 can be simplified to 3. We could do that through expansion, but I'm just going to write it like this for now. I know that the square root of 9 is 3, so therefore negative 4 times 3 becomes negative 12. I bring down the 3 square root 3. These do not have like radicands. 12 is a whole number. This is an irrational number. I cannot combine these as they are. So my final answer will stay as 3 square root 3 take away 12.